Welcome to the deep dive. Today we're plunging into something that might sound pretty technical up front.
Yeah, we're looking at supporting Cisco devices, specifically drawing from the 800-150 exam material.
Right? The Cisco field technician stuff.
Yeah.
But hold on, even if that exam isn't your goal, I promise there's real practical value here for, well, almost anyone dealing with IT.
Absolutely. We've been digging into practice questions, the explanations, that kind of thing. It's like getting an insider's peek.
Exactly. We're not trying to prep you for the test.
No, not at all.
Instead, we want to use this material to, pull out the core knowledge, what really matters in the field.
Things like remote server management.
Yeah, when the server's basically unreachable.
Or best practices for swapping out hardware. Like, what do you really need to do first?
And verifying connections, making sure the wires are actually working.
Understanding key bits of architecture, like Cisco UCS.
And how you actually get software updates onto these devices.
Right. So our mission today is to distill all that down.
It's a foundational stuff, really, even if you just rely on the network working. Okay, let's start with maybe the scariest scenario. Server trouble, middle of the night.
Yeah, and that brings us to managing servers remotely, even when they're completely off or, crashed.
That sounds useful.
It's where the Cisco Integrated Management Controller comes in, the CIMC, found in UCS C-Series servers.
CIMC. Okay, so what's its, main job?
Its primary function is providing out-of-band management.
Out of band, meaning?
Think of it as a totally separate path, a secret channel direct to the server's hardware.
Ah, so it doesn't rely on the main network connection or the operating system.
Exactly. The CIMC is basically a small, independent computer living inside the server. It's got its own network port, its own brain, works, even if the main server OS is completely dead.
Okay, so why is that separate path such a big deal?
Well, the practical benefit is huge. It lets you remotely check hardware health temps, fans, power supplies, all that.
Even if the server won't boot.
Yes. And you can do firmware updates, reinstall the OS, serious troubleshooting, all remotely. Doesn't matter if the server's on or off, or if its main network is down.
So you could be sitting at home.
Exactly. Imagine being able to diagnose, maybe even fix, a critical server issue at 3 a.m. without actually driving to the data center.
Wow. Okay, that is a game changer. No more cold data center visits if you can help.
It shifts things towards proactive maintenance, cuts downtime potential. That's the real power.
Makes total sense. It's like having a remote tech built in.
Right.
Okay, so let's say CIMC helped us find a bad part, and now we do have to physically replace something like a whole switch.
Right.
What's the absolute first thing, the non-negotiable step before we even grab a screwdriver?
Yeah, this is crucial field practice. Before you touch a single screw on that old switch, you must meticulously document every single cable connection and label both ends of every cable clearly, durably.
Documentation and labeling. Why so strict? Can't we just, remember where a few cables go?
Famous last words. I mean, maybe for a very simple setup, but network closets, data centers, they get messy fast.
True. Spaghetti junction sometimes.
Without precise documentation and labels, you're running a massive risk when you reconnect the new switch, plugging things into the wrong ports.
Ouch. Yeah, I can see that causing chaos.
Oh, it does. Big outages, configuration messes, hours wasted tracing what went wrong.
Okay. Point taken.
Think of it like taking a really detailed photo of your tangled headphone wires before you unplug them. It just saves so much pain later.
Guilty's charged on the headphone wires.
Okay.
Lesson learned for network gear. So, label everything, document everything.
And maybe even note what device is connected to each port, any specific VLANs. The more detail, the better.
Right. So the old switch is out, the new one's in, cables are back, thanks to our amazing labels. Now what? How do we know the physical connections are actually good?
Yeah, verifying that physical layer is step one before you even think about config. It prevents chasing ghosts later.
So how do we do that?
Tools like a TDR, that's time domain reflectometer, or even simpler cable testers are key here.
TDR. Sounds fancy. What's it doing?
It basically sends a little electrical pulse down the cable, copper or fiber.
Like sonar for wires.
Kinda, yeah. It listens for the reflection, the echo, and based on how that signal comes back, it can tell you if there's a break, a A short, maybe a bad connector pin.
So it pinpoints physical faults.
Exactly. Finds breaks, open wires, shorts. The real value is catching those physical problems before you blame the software or configuration.
Oh man, how many hours have been wasted troubleshooting network issues that turn out to be a bad cable?
Way too many. These tools are designed to stop that exact kind of, incredibly frustrating goose chase.
Okay, TDR or cable tester. Check the physical layer first.
Okay.
Got it. Now, zooming out a bit, let's talk about Cisco's UCS, the Unified Computing System. What's a key piece of that puzzle?
Right. Within the whole UCS world, you really need to understand the fabric interconnect.
Fabric interconnect. Sounds important. Like the central hub.
That's a pretty good way to put it, yeah. It really is the central point for all the server input-output, the I/O connectivity for the entire UCS system.
All I/O. So
Yeah.
network traffic, storage traffic.
Everything. Think of it as the main highway interchange for all data going into and out of all the connected UCS servers. It connects servers to each other, to the main network, and to the storage systems.
So it's more than just a switch then.
Oh yeah, much more. It simplifies things massively. Traditionally, servers had separate network cards, storage adapters, lots of cables, separate management.
Right.
The fabric interconnect sort of virtualizes and consolidates all that. It acts like a smart backplane, pooling resources, handles LAN, SAN, and management traffic over a unified fabric.
Okay, so it brings networking and storage access together for all the servers.
Precisely. It unifies those connections, which simplifies administration, boosts bandwidth, makes the whole system more efficient. It's the single point of connection and management for server I/O in UCS.
Got it. The traffic cop and manager for UCS data.
Yeah.
Okay, let's shift gears one last time. Keeping things up to date. Software upgrades, like updating the OS on a Cisco router, the iOS. How does the router usually get that new software file?
Yeah, updating the Cisco iOS, the operating system on most of their routers and switches, it's critical maintenance.
And how does the file transfer typically happen?
Often it uses a surprisingly simple protocol, TFTP, Trivial File Transfer Protocol.
Trivial. That sounds, well, trivial. Why use that for something so important?
Well, its simplicity is actually its strength in this case.
How so?
When you're upgrading, the router often just needs to download that new iOS image file from a TFTP server somewhere on your network.
Okay.
TFTP is very lightweight. It doesn't have much overhead, doesn't need complex logins or authentication. It's just good at one thing, moving a file from A to B pretty efficiently.
So it's just simpler for the router to grab the file that way.
Yeah, especially during that boot up or upgrade process. It's perfect for just transferring that OS image file. It's fundamental for keeping devices current with features, fixes, and, importantly, security patches.
Makes sense. Keep it simple when you just need the file, though you probably want that TFTP server on a secure network segment, right?
Oh, absolutely. And best practice is always to verify the file after download using checksums, make sure it wasn't corrupted in transit. Simple protocol, but you still need security mindfulness around it.
Right.
Considering how complex IT environments are getting, just constantly evolving, what other areas that seem really technical or specialized on the surface might actually hold surprisingly practical, broadly useful knowledge, even if it seems totally outside your day job right now?
That's interesting. Thinking about where else foundational knowledge might be hiding,
Yeah.
even in seemingly niche areas.
Yeah. It sort of encourages looking beyond the immediate task and appreciating how interconnected all this technology really is.